Okay, so as promised, our session today will be on complex numbers. I think you have seen them, probably you have practiced them even in high school because they're very popular concepts. So for instance, if I say the square root of negative 10, there is no number multiplied or squared by itself would give us a negative 10. So it's not a real number. The square root of negative 1 is not a real number. Now, so meaning what? If I want to give meaning to this, I have to use the complex number. In the complex number, what you need to know is I squared is equal to negative 1. Or I is the square root of negative 1. So the square root of negative 1 would be I. By assigning it a variable to the square root of a negative number, now we are able to solve complex equations. That is basically it. So please make sure to know this concept. It is the same, written in a different format, and then we're going to be okay. So a complex expression is always of the form a plus bi. A is a real number, b is a real number, and this one is what? A complex number. Okay, so but first let me just throw out it could be a review for some of you, but let's just do this. So if I say find the square root of negative 25, now you know about a complex number. I can split this into two, into a complex number and a real number. I could do the square root of negative 1 times the square root of 25, because the square root of negative 1 times the square root of 25 is square root of negative 25. Now I know the square root of 25 is what? 5. What have we said about the square root of negative 1? The other way of saying the square root of negative 1 is I, so you end up with 5i. Okay. So let's do some addition. If you have 5 minus 11i plus 7 plus 4i, okay. Again, adding or combining like terms. So you cannot add 5 and 4i, or you cannot subtract 11i from 5, because this is complex and this is complex. So I'm going to add 5 and 7, which is what? 12. I'm done with my real numbers. With my complex one, negative 11i plus 4i gives us negative 7i. That's it. You're done. Okay? You cannot go any further from here. Probably let me do another one. Okay. Suppose you have negative 5 plus I minus negative 11 minus 6i. Again, combine like terms. Go ahead. You have negative 5 here. Negative 5 minus negative 11 gives us negative 5 plus 11. Minus times minus is plus. So negative 5 plus 11 gives us 6. Then you have I minus negative 6i. I minus negative 6i means I plus 6i, which is what? 7i. And you're done. So adding real numbers with complex numbers is not that difficult. Now let's look at probably multiplying them. you have 4i times 3 minus 5i. Now this one asks me to distribute 4i to everything inside. Now in multiplication, it doesn't matter whether it's a real number or a complex number, you have to do multiplications, meaning what you have to distribute everything inside. So now 4 times 3 is 12, and then you have I. 4i times 3 is 12i. Then put negative. 4 times 5 is 20, right? And then I times I is I squared. Okay. Now, you know, in our discussion, I squared is negative 1, right? And I is the square root of negative 1. Here we have I squared. So I'm going to rewrite this 12i minus 20. Oh, my I squared is negative 1. So instead of I squared, I bring down negative 1. Because negative 1 is a real number. Okay. So I'm going to put 12i. So minus times minus gives me plus. And you end up with 20. Look. The complex number, if you multiply a complex number by another complex number, you end up with a real number. So that's the idea behind this exercise. Okay? And if you multiply a real number by a complex number, it ends up being a complex number. Okay. Let me do, how about binomials, multiplying binomials. So you have 7 minus 3i. And you're going to multiply this by negative 2 minus 5i. Use FOIL. That's it. And then, you know, you're going to use one of the expressions, especially the I squared. Okay, so 7 times negative 2 is negative 14. 7 times negative 5 is negative 35i. Negative 3 times negative 2 is positive 6i. And negative 3 times negative 15 is 15. And I times I is I squared. Now, combine like terms. Look, I have minus 14 here. I have minus 35i and plus 6i. We can bring these two together. So you will end up with minus 29i. Plus 15, you have now I squared. I squared is negative 1. Okay. Then we're going to go ahead and minus 14 minus 21i, and negative 1 times 15 is negative 15. Now combine like terms. Minus 14 and minus 15 is minus 29. Then you're going to bring minus 29i, and you're done. Okay, so that is what we mean by multiplication. Now, when we are dealing with division, it's a new animal. So you would be asked 3i over 4 plus I, and you are asked divide and or simplify 3i over 4 plus I. When you are doing that, you want to get rid of the complex number from the denominator. That's what it means by simplifying. I want to take you to a concept of the difference of two squares. So for instance, if you have x plus 2, x minus 2, you have seen this in 1 and 5. The middle term disappears, so all you need to do is what? X times x is what? X squared, and 2 times negative 2 is negative 4. The middle term goes away. So both these numbers are conjugates of each other. So we have now a concept called conjugates. The conjugates, when you multiply them, the middle term disappears. it is an important concept in order to solve complex number when we have division. So ask yourself, what is the conjugate of 4 plus I? I know what it is. It is 4 minus I. But since I brought 4 minus I also have to bring what? 4 minus I to the top. What this conjugate does to the denominator is it gets rid of the complex number. This is what we want to do. So go ahead and do this. 3i times 4 gives us 12i, right? And 3i times negative I is negative 3i squared. Now look what happens for the bottom. Whether you do the FOIL and go ahead and do knowing full well that the middle term disappears, I don't have to do the FOIL. I'm just going to go ahead. 4 times 4 is 16. Plus times minus is minus. I times I is I squared. Okay? I squared. Now, let me go to the top. So this would be 12i. You know your I squared is negative 1, so this would be minus 3 times negative 1. Okay? I'm doing it step by step so that you can see the logical outcome of it. And then 16 minus negative 1. Okay? Then I would have 12i. Multiply negative 3 by negative 1, you're going to get positive 3. And look what happens to the bottom. 16 minus negative 1 is 16 plus 1, which is 17. That was my task, to change this complex number into a real number. And that's what we mean, divide and simplify a complex number. Always look for the conjugate. Okay? So, probably let me do one more. So you have 7 plus 4i. Okay. And you have 2 minus 5i. Okay. Then 0 in on the denominator, 2 minus 5i. What is the conjugate of 2 minus 5i? It is 2 plus 5i. Do the same thing for 2 plus 5i at the top. Okay. Now let's go ahead and do the FOIL for the numerator. 7 times 2 is 14, plus 35i, plus 8i, plus 20i squared. If I do the FOIL, this is what I'm going to get. And as you know, 2 minus 5i and 2 plus 5i, go ahead and 2 times 2 is 4, minus times plus is minus, 5i times 5i is 25i squared. Make sure to put a parenthesis because there could be a problem in writing the final solution, which sign that you are going to use, because I squared is always a negative number. You need to watch out. Okay, so 14, 35 and 8 gives me 43i, and 20i squared would be, I squared would be negative 1, and negative 1 times 20 gives you negative 20. Okay. Over 4 minus, now you have what? Negative 25, because I squared is negative 1. We're almost done. 14 minus 20 is negative 6, plus 43i, over 4 minus negative 25 is 4 plus 25, which is 29. We're done. Okay. I think that takes care of the complex equations.